Hey guys, welcome. This is our review for the tests. I'm going to be going over the study guide, so if you have any questions on anything, hopefully we'll be able to answer them. So make sure you have your study guide out. If you don't have the study guide out, you won't be able to do these problems. We're going to skip over number one. A solution to a system of linear equation represents either an ordered pair, it could be a line, it could be a shaded region. There's a lot of actual different answers for that one. But we're going to go stick with the numbers. So let's do number 2 first off. Okay. Number 2 says, tell whether the ordered pair is the solution of the system. So what we need to do for this one, we need to go ahead and plug in the ordered pair, which is -5, 1. And that's my x and y value, and I'm going to plug it into my two equations. Okay. So I'm going to plug into the bottom equation first. We get x plus 2y equals -1. So I'm going to plug in -5 plus 2 times 1 equals -1. If I do this, I get -5 plus 2 equals -1. That's -3 equals -1. This is not a true statement, so that's not true. And since I already got a not true, I don't actually have to plug it into the other equation, because if it doesn't work for one, it's not going to work for either. So my answer for number 2 is going to be no solution. This is not a solution to my system. Sorry, I should say not a solution. Okay. All right. Moving on to the next one. Number 3, it asks you to go ahead and graph this. So let's go ahead and we're going to graph this real quick. And this is going to be a rough graph just because I don't have a graph on here. But we start out with y equals x. Now y equals x is a very interesting line. If y equals 1, that means x equals 1. If y equals 2, x equals 2. So what you actually get is this great, here's 1, 1, here's 2, 2. You're going to get this great vertical line. And it's going to kind of go all the way through. Okay, so that's the y equals x line. Easy to graph. The next line is y equals -x plus 2. So this one right here, we get -1 over 1 is my slope, and I start at +2. So start at +2, go down 1 over 1, down 1 over 1. I'm going to get a graph that goes through here, and here's my point, and that's at 1, 1. Okay, so again, we need to use our slope, point slope form to graph, which is y equals mx plus b. Start with my b, that's why I started here, blue, number 2. My slope was -1 over 1, down 1 over 1. All right. Okay, so that was number 3. Number 4, we're going to do solve by substitution. All right, so we get x plus 4y equals 6, and then we get x equals -3y plus 4. So what we're going to do is we're basically going to say this piece here is going to sub in for x in the other equation. It's already solved for x. So we get -3y plus 4 is going to start us out, plus what we originally had there, which is the 4y, equals 6. Okay, we're going to combine like terms, 3y and 4y. That's going to just be y plus 4 equals 6. Subtract the 4. We get y equals 2. Okay, we have to find both answers, so we got to take 2 and plug it back in, one of the original equations. I'm going to choose to plug it into the one that's already solved for x. So I'm going to get x equals -3, but instead of y, we're going to plug in 2. It's going to be -6 plus 4, so x is going to equal -2. And that's my answer. If I want to write it as an ordered pair, it would be -2, 2. All right, we have another substitution problem coming up on number 5. And we get 2x plus y equals 1, and we get y equals x minus 5. Okay, again, we're going to substitute our values in, so this is going to get subbed in for y. So we'll get 2x plus, and instead of y, we're going to plug in x minus 5 equals 1. Combine like terms, that's going to be 3x minus 5 equals 1, add the 5, 3x equals 6, divide by 3, x equals 2. Once I get x, I'm going to plug it back in to one of my original equations. I'll pick this bottom one. Y equals 2 minus 5, so y equals negative 3. There's my two answers. Number 6, elimination. Okay, so here we get an elimination problem. We get negative x plus 2y equals 15, and we get negative x plus 3y equals 19. I'm trying to get the same coefficient in the front, so we got 3 and 2, I got negative 1 and negative 1. Those are the same. So what I'm going to do is I'm actually going to multiply this whole equation by a negative 1, and that's going to make my life a little easier. So that's going to become a positive x, it's going to be a negative 2y, and that's going to be a negative 15. So I'm going to combine these two. Okay, it's kind of confusing having this line here, so I'm going to erase that. So hopefully that doesn't confuse us. Okay. All right. Now let's go ahead and do some adding. We're going to add these two equations. Negative x plus x, that's going to go to 0. 3 plus negative 2y, that's just y, and 19 minus 15, that's going to be 4. Now I got to take this, plug it back into one of the original equations. I'm going to actually plug it into this bottom equation here, which is x equals x minus 2 times 4 equals negative 15. That's going to be x minus 8 equals negative 15. Add the 8, and we actually get x equals, that's going to become negative 7. Number 8. So many problems. Alright, we can choose any method we like for this problem. We get 2x minus 5y equals negative 7, and 5x minus 3y equals 11. Again, I want to get the same coefficient, so I'm actually going to go ahead and multiply the top by a negative 5, and I'm going to multiply the bottom by a positive 2, and what that's going to do is going to make this one negative 10 and this one's positive 10. So we'll go ahead and rewrite this one first. So we'll get 10x minus 6y equals 22, and then this one is going to be negative 10x plus 25y equals 35. Add those. This is going to cancel. Here we'll get 19y equals, and that's going to be 57. And 19 goes into that. Now you can use a calculator on the test as long as you pass that integers quiz. So we get 3. This actually goes in 3 perfectly. And I use my calculator for that, which is okay. So y equals 3. Now we got to plug it back into the original equation. So one of the original ones. So I'm just going to go ahead and plug it into the top one. We get 2x minus 5 times 3 equals negative 7. It's going to be 2x minus 15 equals negative 7. Add the 15. I get 2x is going to equal 8, so x is going to equal 4 once we divide by 2. So 4 comma 3. Alright, number 9, again, a solve any method we like. We get 4x minus 2y equals negative 6, and we get negative 2x plus y equals 5. They're lined up already, so in fact if I multiply the bottom by 2, I'm going to get the x's to cancel. So let's go ahead and do that. So we'll multiply that, we get negative 4x plus 2y equals 10. And my other equation, I'm just going to rewrite it. 4x minus 2y equals negative 6. Add the equations. That cancels, and we get 0 equals 4. That's not true, so this is actually no solution. These two lines will never meet. Okay, and that's okay. Not the greatest thing in the world, but we can do that. All right, next. Number 10, we have a word problem. Cool. At a store in the mall, Stephanie bought 3 sweaters, returned 1 pair of shoes. Miss Black bought 2 sweaters and 4 pairs of shoes. Stephanie's bill was 20 and Miss Black's was 200. Right? Solve a system equation. Determine how much 1 sweater costs and how much 1 pair of shoes costs. Make sure to define your variables. Okay, well, we have sweaters and we have shoes. We'll call sweaters W and shoes S. All right, we have 2 equations, one dealing with Stephanie and one dealing with Mrs. Black. So Stephanie is going to be 3W, because she bought 3 sweaters and returned 1 pair of shoes. That's going to be minus S. And she spent a total of $20. Miss Black, however, she bought 2 sweaters. She bought 4 pairs of shoes and spent $200. So here's my system. Notice none of my numbers are opposites, so we're going to have to do some multiplying. If I multiply this by 4, I'll have the s's cancel out. So we'll rewrite that equation down here. 4 times 3 is going to be 12w minus 4s equals 4 times 2 is 12, so that's going to be 120. Add the 2 equations, that's going to be 14w equals, because that cancels, that's going to be 320. And we want to go ahead and divide that in. Again, we can use a calculator, not a problem. So we're going to go ahead and have a calculator off screen. Just going to take 320 divided by 14. And I did do that correctly, right? 4 times 3 is 12. Okay, whoops, sorry, I made a mistake. Let's go back and fix that. This should be 80, right? 4 times 20 is 80. I had 3 in my mind for some reason, so this is 80. My bad. So that makes 280. Divide by 14, that makes it a lot easier. W, so the cost of a sweater is going to be 280 divided by 14. Much easier math to do. So that's going to be $20. $20 for a sweater. And we can plug it back into the equation. I'll plug it into the bottom one, so we get 2 times $20 plus 4 times shoes. I don't know why I put it in parentheses, but I did. So that's going to be 40 plus 4s equals 200. And then subtract 40. And 4s is going to equal 160. So the shoes, 4 goes into 160. Again, if you need, you can use a calculator. $40. So there's the price of both. Okay, and there we go. Last one says, how can you determine without solving how many solutions a system of equations will have? Okay, so how can you determine without solving? We want to look at, so this is number 11, we want to look at slope. Okay. If they have the same slope, they could be parallel, which means they're either not going to meet. So if we have the same slope, notice these 2 lines will never meet. Okay? So if it's same, we got to be careful. Or if it's the same slope, it might be the exact same line. And in fact, if that was true, they would always meet. So slope is the way we do that. We want to check for slope. So if I said y equals 2x plus 1 and y equals 2x plus 2, they have the same slope, different y-intercepts, so they're different lines, so they'll never meet. If this was a 2, then they would always meet, so we'd have an infinite amount of solutions. So slope is our key. Okay, we're going to stop the video there where I went through everything. The last piece is graphing. Now graphing's kind of hard to show on here, so we're going to go ahead and not do the graphing problem on here, and we'll stop it at that. Alright guys, thanks for the video. Bye.